sit down and there's no cable or?
No, it's wireless. Because that's why I'm using this. And I'm using this microphone instead of this one.
Oh, okay.
And it'll be fine.
But very cool if you Amadeus currently has the...
Oh, he is going to use that, okay.
Yeah. Why not?
I'm good.
Amadeus, can you give me a mic check? 1, 2, 1, 2. It's not on. Yeah. Okay, try again.
Okay, you hear me? All right. Okay, everyone. Finally, some results from the BattleMeshV8, which is why we are all here, I guess. Yes. We had quite a lot of volunteers actually this year, and that was really nice because last year we only had a few people working on the tests. That really changed this year.
Actually, at the moment, sorry to interrupt, but we have an online presentation in a village, a new village that wants to join our community network in Sarantaboro.gr.
Thank you. All right. Yes, we had quite a lot of volunteers, and so we decided to split up the test teams. So it's usually we have the YBAT team that is running the YBAT firmware, where you can very easily deploy experiments to many nodes and collect data back. And we had another team that was just compiling the OpenWRT trunk and running some tests on that. And this is the group that I'm now representing, so we want to share the results from the group that was not using YBAT, but I guess there will be some results from the YBAT team afterwards as well, because they didn't manage to finish that in time right now because to some issues. Yeah. What have we done? You can read it. We have some implementations of different protocols here. And basically, we managed to test all of them, which is pretty good. And I will show you what we have done. Thanks to Nemesis. He did a great job with the graphics. And everything else. And yeah, as you can see, we have a nice test bed with 10 routers, and we have 2 routers attached to the edges, which would be client and server, and then we have 8 other nodes in between that are building a full mesh. So we can run tests from the client against the server crossing this full mesh, basically. That's the idea in the testbed. So we can use different tools to make some measurements, like ping to get some hop counts or TTLs or RTTs, which is used to get the hop count from one router to another and to use to get the time a packet travels around. And we were also using iPerf, which is used to measure the bandwidth on the client and server. So we were thinking, what should we do? And you know, there is some preparation before the BattleMesh, but we had to rethink some stuff actually. And I mean, it is clear that we have an indoor setup. We had no long shots or any outdoor routers. We were just using indoor routers on a multi-channel setup, which would be 2.4 and 5 gigahertz. Then we wanted to test a real world scenario, right? I mean, you can go to a lab and have some routers there and there will be perfect results. But we want to do is get actual real world results, because that's what all of you are doing in the communities. You want to test real infrastructures, real scenarios. So we could do that because we have a lot of other routers here. We have so many clients, all your laptops and stuff, so it's pretty much real world. We've done some measurements. You can read it here, which I come to that later. We made some nice graphs so you can easily understand what the test data is actually about. It's not so easy to read that just from the actual data, because we collected many CSV files with a lot of stuff in it, and we managed to make some nice graphs, human readable graphs out of that. Yeah, as you can see in the last bullet, it's done with the all library. That's a graphic library. You can do many stuff with that. Matthew has a great knowledge with the all library that I personally don't have, but he was able to make some very good stuff out of that. Okay. When it started, what did we have to do? At first, obviously, we have to have some firmware, so we go to the OpenWRT website, downloaded the trunk, and started compiling. We were including everything that we needed, which is some testing tools, and of course, the routing daemons. Then we were going to flash all the 10 routers. You can see the model. It's a dual band router with USB attached. It's a different standard hardware. And this was actually the easy part. Nemesis did also a lot of that, and he can do that at night with his eyes closed and drunk, you know.
Yay for being drunk!
Yes. You are drunk all the way, I see that. And then comes the configuration. And you know what that means. You have to go in all the UCI configurations, you have to tweak settings. You have to do tweak settings twice because something went wrong. Actually, we were able to do OLS RD and Babel in maybe 1 hour or so, because there is the default configurations. We have the experts at the conference, so we just ask them. And the other stuff took the rest of the time, which I'm not willing to say how long that was. All right.
It was difficult to make them coexist together. That maybe it would have been not so difficult to do just one.
Yes, Nemesis just said the difficulty is to bring all the protocols in one router. I mean, typically in your community network you use just one protocol, but we had to configure all the protocols on one device, which is difficult if you have routing on layer 2 and routing on layer 3, so we have to reconfigure interfaces and some other stuff in order to switch the protocols. So we did some scripts to do that automatically, so we could switch the routing daemon and all 10 routers automatically, so we didn't have to log into SSH manually, which is not a good idea actually. And yeah. Then we deployed the routers around the venue. You can see some nice photos here. You know, we had to put some chairs over the routers so that nobody will stumble over that. And a nice laptop from Henning, who was running a lot of the test part with his laptop. And yes, that's pretty much the setup. I'm sure you have seen it outside on the stage, or the router stuff, which is still there. You can look it up. All right. You want to see some results? I can feel that. Yes. Okay, now let's go to the interesting part. And I want Matthew to come to me, because he's the all library graphics guy, so he was able to make some nice stuff out of it. Yes, give a round of applause.
Thanks, Amadeus, for all the beginning of that presentation. So, well, you were very pressed to see all that results, and so we didn't have many time, so it's perfect. It's perhaps not the best presentation you will ever seen, but anyway, we will do what we can. So at least we have results. So first I will present how to read this kind of curve. So there is only one information here, the RTT. Don't look for time or other things. There is just the RTT, and at the right, as the y-axis, is just the frequency of the packets for a certain RTT. So for example, what you see is that 80% of the packets are less than 50 milliseconds. So that's the way you want to read the graph. And the most your graph is like that, the better it is, because if it's exactly like that, it means that all packets are very fast. And conversely, if your graph is like that, it's very bad. Okay, that's basically the thing you must think about that. I will come back to that graphic at the end just to have a better presentation, but I will go through all the kind of graphics that we have. So this is the throughput. So that graph is actually very good. You didn't have a curve which go from here until there. What you see is just that we ask for a packet which have 10 megabits per second, and we have 10 megabits per second. We have this curve for every protocol, so I will not push that curve again. Here is the opcount, so it's calculated based on the TTL and minus the initial value of the TTL. So first there is a little flow probably about that, because well, I will come back to the first graph to explain that. Yep, sorry. Because if we send a packet with TTL 64, then it may arrive with A with 63 and then 62. So if you see two hops, it's not that there is one hop here and one hop here, but there is probably a third hop. So, oops. Here you see 3 hops, but there is probably 4, and there is some graph which is written only 2 hops, and in fact it should be 3. But I will fix that. But again, if you were kind enough to wait for 2 o'clock to see the graph, it may be possible, but you know. So okay, and so well. You will see details, but that kind of graph is not very interesting, so I will not come back to that graph. This one shows duplicates, so if you see, I will again not show that because all protocols should have 0 duplicates, but what we've seen is that there may be a default in the kernel such that it appears on some curves to have duplicates. So for example, the OLSR2 on that test has almost always, I mean, 2 packets which are duplicates, which means that when we send one ICMP ping, we receive 3 or 2 ICMP in result. Anyway, so come back to the real results, what you're looking for. So here is OLSRV1. So you see an RTT curve with around 80% of the packet which are under 50 RTT. Oh yes, just before. Another flow of my graphs currently, it will be fixed in a future version, is that all the graph doesn't have the same scale. So be wary. Here the maximum packet is around 400 milliseconds. And here is the graph you're habituated to. So it is the RTT in function of the time. So you see that there is some peak sometimes, but as shows the previous graph, it is most of the time very regular. Okay, so now OLSRV2, which is probably the best protocol for that test bed. So you see the scale is 150. So if you come back to 50, you have almost all packets which are under 50 milliseconds. So it's a very, very interesting result and very good result. So congratulations to OSRV2. And again, the scale, oops, what I do? Okay, the scale is at 100, so you see that every packet is very good, very clean. You didn't have big peak or anyway. So on that test, it's good. Oh, so that's the kind of thing that we show. So here we see that there is around 3 hops and sometimes 4 hops. Okay, so now come to Babel. So again, we have a curve with some kind of results which go around 80%. So it's pretty the same for our protocol anyway. So except OSR.
The scale.
Sorry?
No, he announced that he didn't have time to normalize the scale.
But
The scale, this is 1,400 on the right.
yeah, that is very, very different. If I didn't announce that the scale was not the same, we could say, oh, look at Babel and quickly switch the slide. Okay. So the normal thing, so you see that there is 2 lost packets of oil, perhaps not lost, but I don't know, going to search for mushrooms or I don't know. Well, and anyway, the rest of the time it's a good result. So Neo Batman ADV, which has also good results. You see, again, you have 80%. Again, the scale is completely random. So it's pretty the same results. And against perhaps mushroom, I don't know what packets actually love, but anyway, it's also a pretty good curve. And finally, or not, I don't remember. And BMX7. So again, you have it's a little bit less good, but anyway, it's quite the same. And you have on that curve, you see that there is much flow, but now it's on one experiment. You probably can't generalize the global result. Absolutely, and that's why I say that on one experiment you can't say that protocol is better and that.
And maybe we should say this is a ping test while we have a 10 megabit stream running in parallel to the stream and having another 10 megabit stream running cross between 2 other routers. So there's traffic in the network. This is not a no-load situation, but it was not loaded enough to get less than 10 megabit. So all of this is under some load.
Thanks. Okay, and on that one you see that there is the strange thing with, yes, on that one you see the strange thing with, so there is 2 hops and that's not possible to have 2 hops because you have at least the hop to the mesh network and the hop to the server. So between the two, either BMX7 makes dark magic, either there is a bug on the curve. Okay, so this was the first visit, but I hear that there is other bench which are finished.
I can share a little bit. Let me. Sure. We have a second test running. It's not complete. It was not completely done for Batman Advanced. So this is just rolling the connections before running into the room.
Yep. Sorry.
So nobody is seeing this.
1, 2. There is that USB key which has been very useful, but we didn't remember to which it belongs. Oh, perfect. Yes.
Aha. All right. Hello. So, hello. My name is Toki. I like to blow up networks, and I've been trying to do that with this one as well. So, what we did now was we ran a series of other tests where instead of just having a 10 megabit UDP iPerf stream, we run 4 different TCP streams in each direction and then measure the latency. And as you can see here, this is actually the good one. So I'm going to stand out here so I can see what I'm doing myself. Yes, and Batman Advanced didn't finish running, so that's not there. But as you can see here, this is about 250 milliseconds, and about half of all the latency samples over this 1 minute long test have 250 milliseconds of end-to-end latency through that test bed. And when it's unloaded, it should be a couple of milliseconds. So my point here is mostly to say, they all suck. Wi-Fi sucks. It's not so much, my point is not so much to compare the different protocols, also because it's a fairly small sample size, but more to say, this blows up. And to illustrate that, this is the 4 TCP streams in each direction, all running normal, no diff-serve marking, best effort. And we can do even worse than that. So if we switch to this one, you can see the scale changed.
Okay.
Yes?
Could we know the topology?
Same topology, same test bed.
Okay.
Same script, same, yeah. So here you have up to 500 milliseconds at about half, somewhere 300, 400 milliseconds, go all the way up to 3,500, and most of the protocols drop 10% of all the packets. And this is what happens when you turn on diffserv and run the different tests. And
It's BMX7, yes?
Probably, yes. I think that might be a typo from the test.
Just explanation. I think the error comes from that the name of the startup script is BMX6, but it loads BMX7 daemon. So that's why the folder for the data was named BMX6.
Yes. So this is the explanation for what happened before, where you can see over time. This is Babel. I'll show the others in a bit. This is nice, stable, low latency in the first 5 seconds. Then after 5 seconds, we start up the TCP flows, and they struggle to get anything through. You can see here the EF marking eats a lot of bandwidth in both of them. And of course, the latency goes way up. And this pattern is repeated, for all the tests. With weird spikes and weird holes and 3,000 milliseconds of delay. So if we go back and look at it all side by side, you can see the downloads, the uploads, and the ping. The ping scale is over here. This is the median. So again, about 250 milliseconds. And something similar for the best effort. And this is, by the way, all the test results. This is the test tool I'm using to plot it is open source, and it plots this in real time, and you can switch around and explore data. So look at the, I'm assuming we're uploading all the data files. So look at them, go around, have a look through. So the main point of this is just that, one, when you do these kinds of tests, try to be as unkind to the network as you can. This is a very nice way to do that, because BitTorrent is 50, 100, 200 streams. Your network is probably going to experience this at some point, and measuring these things at the same time shows you some very bad behavior that you might want to look into. And Dave gave you an explanation earlier today why this is happening with Wi-Fi. And of course, my guess would be that if you did this for a little bit longer than the 1 second we run this test, you might even get some of the routing protocols to start dropping routes. And that is, of course, even worse. Yeah, questions? Cool.
Before everyone leaves, I would like to ask for a round of applause for the person doing the actual work in OSRV2.
Oh, sorry.
Also, the rest of the experiments team has done pretty good this year. I'm surprised we have, it's not 21 o'clock now, and we have actual test results. That's crazy, that's good. I hope that would be every year so. Please have a round of applause for the whole test results team. And the test results team, please stand up. Everyone.
Running why that? That is that was working two additions. Okay.
I know that.
Yeah, so what should I do? Thanks. So the YBET team has some problems updating YBET to the latest trunk of OpenWRT. They already had a version running before coming here, but the upgrade caused a lot of problems. I was not really involved since the beginning helping them, so perhaps, I don't know if Manos can say something about this phase. So I think we should learn from our errors. Yeah.
Do you want to say more the generic stuff first about learning? And I can say about we, but it's just details.
Okay, perhaps we can have an offline session or something on a mailing list to discuss about this. But I think the main feedback that I received from the people I talked to is that we need to set a deadline before the event to freeze the OpenWRT trunk. And I think we can tweak WeBed to let the testers use several approaches at the same time. That is, right now it's a bit ossified on having scripts that have to be uploaded, and it's very difficult to debug what's happening there. So I think we need to keep the fully automated approach, but also to have something in the middle. That's more or less the summary of what I learned. And yeah, and also we should not upgrade to trunk on Monday. We always make the same error.
Maybe we should look into a stable branch version of YBAT next time. Base it on the latest stable OpenWRT branch and work from there. We might miss a few features, but the chances are higher that it will work.
Like pet patches could even be individually cherry-picked. Like if developers present want to test their specific additions, which are more mainstream after the latest release, then it's probably wiser to cherry-pick individually.
Okay. Which version was OpenWRT before?
It doesn't matter how you put it.
Before,
At
by
least you have to make clear that you are agreeing before the BattleMesh which version to use or which state to use.
Yeah, exactly. I think that's the thing. YBAT had barrier breaker before coming here, but it looks like that would have left us without the latest features of some protocols. So that was the main problem that the YBAT people faced. Okay. I don't know if Manus wants to say something else.
Also about the other teams with the things we discussed. Bit the organization, I think, more in terms of that we kind of decide all together how we split the effort and evaluate every short amount of time, how much time we have left, so we can know how to split the effort and we don't everyone try on their own to do their stuff, or we just communicate more officially between we give updates as Roger reminded me that we were doing on the last BattleMesh, so we could communicate and say, okay, 3 days left, this thing is not going to work, let's all work in one thing. So a bit optimize our work between and not having, it's not a competition between us. I mean, it's a work together. So, and I mean, sometimes there are flames between the different test beds. I mean, I'm not here to promote but I'm here to assist so that you can use it for the protocol developers and for the experiments. And I think everyone's approach should be like that. And so there should be a better communication. And I think we can talk on the mailing list also. I was proposing maybe having a configuration team that specifically contacts the developers and takes the configurations of the protocols, because I understood it also took a lot of time. And also a team about preparing the scripts that are going to run the experiments. Henning here.
Just as a thing we learned during our effort, it doesn't make sense to define a configuration before you have the testbed running. We did this, we uploaded the configuration, we got the testbed running, and we spent, I think, a total of at least 6 to 12 hours fixing small and large bugs in configuration. So yes, you can prepare configuration, we tried to do it, and then you have to upload it on the testnet and test it directly. So having a configuration team of its own, it's a nice idea, but you will need time on real hardware with a real testbed to see if the configuration is running. I think we spent at least half an hour to 1 hour effort only to notice that one of the routers had accidentally copied a configuration of one routing protocol over the other routing protocol. I was wondering like hell why all of the D2 was running on only 2 and not 4 interfaces until I noticed I was working with a bubble configuration, and it accidentally worked a little bit.
In short, our experience is that the first 90% of the work takes 90% of the time, and the last 10% takes 90% of the time again.
If there is any volunteer team also, WeBet is available all the year long. We have a testbed in Barcelona online available. Debugging is harder because you don't have physical access. So 1 month earlier we decide the version, we compile the firmware, and just a team of 2-3 people, because I can do everything myself, obviously, can do that, and we can come here ready. Or we can decide that we don't want we, but I mean, it's our decision, it's not my decision. I'm just trying to evaluate the situation, and we can talk about it.
Does V8 work within a QEMU emulation, so in virtual machines?
Yeah, so there was a proposal of compiling a version for x86 and creating virtual machines.
Why not embedded QEMU targets? Like would be a bit smarter, where you would also, like the default configuration much more resembles a router device than x86 images for OpenWRT, which are more focused towards being one of the things.
Okay, we will need also the appropriate hardware and people to do that, but of course. I mean, the idea is to encounter a way to be prepared with a minimum amount of effort before the event. If that is the best way, yeah, we should go for that. That's my approach. So we can reflect more on the mailing lists altogether. We can create also, I think, we can create also a TextPad for that, about evaluating a bit techniques, how we could start earlier next year, and what could we do, and see what is more feasible, because we all have other stuff to do also. So work on that online. Okay, that's it.
In any case, I think that you guys deserve also a good applause, because you did a good job. You did debug a lot of stuff, and I think it's part of the matter.
As always, you're perfectly right. So, what we wanted to do here was to obtain a number of results in static topology and move on to dynamic tests. First criteria was getting results now. Now, the two tests that we were planning was a test which had a simple topology, in which all routing protocols cross a given route. And then we kill this router and we count how many ping packets have been lost. Simple test. Very difficult to do because it requires human interaction. Okay. Second test that we wanted to do was the row routers that are communicating just fine. Okay, but those are not a full mesh. Okay, but neighbors communicate, no problem, solid links, and so on. And then there is a human being with some machine on wheels that is transporting a map and checking how many. Okay, those are the tests work and we never got around to even working on it.
There's still
mobility tests are very important. Mobility tests are something that every single BattleMesh since I was born has failed first. There were some, I remember in Catalonia. Am I wrong? Was it?
Yes, there were there was
last year we were able to do it.
There were some, but those are extremely difficult, extremely error-prone. And in a situation in which you're testing hybrid and product culture, we don't manage. So that's definitely something we need to think about. Behavioral probabilities, very important, and we have always so yes, we consider that this is something that we can do.
Did the testing team also collect data about the CPU overhead and the protocol overhead?
No. We didn't. I promise it's not.
Yeah. Of course, the amount of nodes is not very demanding, so we cannot see the performance impact from that. But I have to congratulate Henry, because I think he's the only one that has now a very useful metric implemented in OSR version 2, because he actually uses ThinkSpeed, which is a great achievement. And all the other protocols that learn from that. I think copying the method is probably straightforward, because he actually has it in a very meaningful way. That sounds really sound to me.
I'm curious, during this time I was likely capturing air caps of the actual air throughout the entire event. And unfortunately, my laptop was almost constantly in use. Did anyone do an air capture this week? So I would argue that the future event, we could have several laptops capturing the actual air throughout the entire event, just to have a little statistical background noise to look at. That would be great.
Just a comment about maybe a metric. One part of my work in the last 4 years as part of the confined network was to get a standardized document to the IETF exactly about this metric, because lots of people there have talked about the metric, but it's still the only metric that has been documented in a protocol document, not in a scientific paper. So if you want to know how it currently works, there's a document online that you can read. And I know at least the people at the NL, which have the second, which has also an orders R and the orders of V2 implementation, have successfully implemented it based on this text. So it should be possible without having to read through all the code.
Another thing to mention is that last year in Denmark,
Leipzig.
so the last before, the year before, I think it was in Denmark, we started to make tests in the night. So we prepared the test network and did all the testing from the host, which means that we have EDA.
We thought we had everything resolved at, I think, 8 p.m. yesterday, and then there was a small issue, and another small issue, and we tried to get it running, and I think at 1 a.m. in the morning, or a little bit later, we just gave up and said, okay, we have to do it. So we tried to do this. The tests we have been doing have been fully automatic. It was a single script running 5 protocols, doing 4 tests on each. It took nearly 3 hours to run. And we would have liked to do this 2 or 3 times during the night, but unfortunately there were quite a bit of issues to resolve. And it's the small, like you said, it's the small things that take lots of time in debugging to find out what is going wrong.
So, are there any other comments about the experiments? Any congratulations or nasty stuff? Maybe?
Any volunteer to put up good documentation with the test results, please get in touch because I'll be working on it, but I will need your help.
Yeah, there was a call for native English speakers at the beginning. Did they already read it? Corrected all the issues with our non-native English language?
I told them to not bother because we have to update all the text and remove the scenarios we didn't perform, so it would have been useless for them to work on something we would have changed, so it's better to do it after iteration.
Alright, then in 2 weeks. In 2 weeks we need a couple of English native speakers to watch over the text, if they are correct English or would be in shit. So, any last comment?
As someone who's only been here one time, is there any analysis that goes on after this data has been released as we've seen that?
I think that we have at least found one issue, small or large, for each of the routing protocols. The largest one in Waterstar version 1, where a misconfiguration of a single node managed to crash all the other routing agents, which in fact was quite funny because the routes were still there, so we could only reach the only node that was still running the routing agent. This was really, really horrible to debug. We couldn't understand why this thing is not working anymore. It should work, and we discovered that the rest of the network was not working anymore. They were just a static routes left. So I think everyone that has a protocol here has some main issues to resolve or to improve. I think that's the primary reason why we started this event.
But will there be an overall analysis to explain?
So I think that's a very good question. So I'll give 2 answers because that's such a good question that it deserves more than just one answer. The first one is when you develop a protocol, you are looking at test cases that interest you. Okay? So I will have my particular test cases that I think are important. Henning will have his, Axel will have his, that are completely different. And we tend to look at those test cases. And then you go to a meeting where all sorts of weird people are present from your point of view. And they have test cases that are completely different from yours. And suddenly they break your protocol, or you break theirs. I mean, it doesn't matter. The point is that you go and you think, that's strange. I had checked everything, but this case had never occurred to me. What sane person would do something like that? And then you think, actually, they're pretty sane people, and they did that. Okay, so you think about it. The first reaction is to be really irritated, like no sane person would do that. And then you think about it, and you think, well, that is clearly a flaw. I'm claiming this is a generalist protocol. I need to look at it. So we all, if you ask any of the protocol implementers here, they will tell you about an epiphany they had after a particular BattleMesh where people tested their protocol in something it was not designed to do. Mine was it was very painful. Okay, but if you go after the meeting and ask the other implementers, they will tell you quite similar stuff. So we do go through the data, we do look at it, and quite often we find a way to make it. The second answer, which is the one you're waiting for, is there somebody doing real scientific work on the data that is being output like that and producing an actual real scientific report out
Will
of
there be
it?
something published?
The question is just about publishing.
Yeah.
I told that we'd be working on the documentation.
we will have documentation published where it's already there, but it was a draft. So the idea is to remove the scenarios that were not performed, keep only those ones that were performed, link all the configuration and scripts to perform the test, the raw data, and the scripts to extract the graphs, publish the graphs, and hopefully also how to interpret the graphs. And but I don't want the responsibility to write any conclusion on those documents. But that's what I want to do.
Yeah, I mean, just
At least what I want to do, or what we want to do in our community network, we want to build up the same test again with Vibet, so that it's reproducible, and we will put on a step-by-step guide on our wiki how to reproduce, and especially the graphs must be generated automatically, and I think it would be a good starting point for the next BattleMesh if we have a Vibet that is learning. Okay? Because we have enough hardware, so real hardware, enough place, and next week we have time, so we will just do it.
Which community?
Why not? So, 5 and down.
Any additions?
Yes.
If you wait long enough, that will be wrong. So, one thing that would be really cool is to go that database somewhere and don't worry too much about the graphs. Just let people do stuff public. Yeah, that's it.
Good.
From the last BattleMesh, we also put public with the scripts and also some slides. You can find it in some GitHub repository. And another thing which happens a bit like the instance, during last year we had the possibility to choose a test course to test the test bed. Another one, a professional one, came from IWNT, from Research Institute, and we did a bit similar test as local. So it's getting too loud. Okay. We did kind of similar test as we did here. For example, we could use a robot which moved along a set of nodes, and this robot was carrying a wireless router, and we did some tests how is the web code converted and so on. And the result of these tests you can also find online in the Kuomina page. If you search for a project called Memo. Because some other people were mentioning kind of the cabinet tests, this could also be interesting.
So, no other comment? Most people say something.
I would still just thank you to all for working hard the whole week. And just to conclude, there is some beer left. That needs to
You find some.
There are 2 boxes of wine in the fridge that need to be cleared out as well. And in addition to this logistics, please take all the trash and things from this room out as you leave it now. And come find me for the invoices, documents, like certificates you were here or whatever bureaucratic stuff you might need. So again, this is over with today. And that's it. So this is officially the end. Now is the official tomorrow to do whatever. Thank you.
I have lost a jacket, so if anybody finds a jacket, and
which color, which size?
It's not sure. It's brown. It's brown. So if anybody finds a jacket and if it's not sure, it's him. So give it to me, please. my wife kills me.
One more thing. So you brought loads of Wi-Fi equipment here. Please make sure you do collect it. If you don't, and there is no sticker on it with the name, we will claim it. So just make sure you take your book, or we will put more notes up in Slovenia. So one way or the other, both works for us. Thank you.
Thank you. So, thanks again. Why don't you turn it off?
Just so.
Okay. Thanks again for everybody who has been here. It was, at least in my opinion, a very great week. We had some test results, which is pretty awesome in my humble opinion, which we didn't have last year, sadly, but this year it worked. So I thank you everybody for being here. We'll see ourselves next year.